Our last video this week is going to look at how we can do data visualization in R. So we're going to look at the same data set again, and just as a review, this was data about whether people preferred advice from human experts or statistical algorithms when making predictions about different subjects, and depending on how far in the future the event was. And here we're looking at our data again. Once again, the first column is an ID column. The second column, month, was about how far into the future the question was. So there were two levels, September and November. September were shorter questions, November were longer questions. The third column is item domain, so it's the subject, in this case, politics or economics. And there are some demographic variables, and the dependent variable is RESP. And here's a little bit more. Once again, the dependent variable RESP ranges from 0 to 100. It was based on a slider where values on the left were the person saying they preferred human advice, and on the right were saying that they preferred advice from the statistical algorithm. So high values are statistical algorithm, low values are human. So we're going to start with just the basic plot functions in R, and this is done with the plot function, conveniently. And this is available in base R. You don't need to add any packages. So if you just put two variables into the plot function, R is going to try to figure out what to do with them. If x is a factor or a categorical variable, you'll get a box plot. If x is numeric, you will get a scatter plot, and y always has to be numeric. So let's take a look at what happens when x is a categorical variable and y is numeric. In this case, x is the item domain and y is the dependent variable, the RESP variable. So here we see our box plot. We see pretty clearly that lower values for politics, higher values for economics, and it's just a pretty standard looking box plot. And here is an example where if we have two numeric variables, so here the x-axis is age, and then the y-axis is again our dependent variable RESP, and here we see a scatter plot. To customize our plots, there are several additional arguments we can include. So the xlab and ylab arguments allow us to name the titles. Main puts a main title on the plot rather than an axis title. COL defines the color of the objects on the plot. LTY would be line type for certain types of line plots. PCH is point shape, and xlim and ylim are the limits on the x and y values, and you use the C function to enter those. So here is our scatter plot again. I changed the x label to age, the y label to preference. I changed the shape so that they weren't empty circles but filled in circles. I changed the color to blue, and I rescaled the x-axis so it goes from 0 to 100. So I'm not going to do too much else with base R. There's some other things you can do, and part of the reason is because I want to talk about ggplot. ggplot2 is an add-on package for R, and it's become the sort of gold standard for data visualization in R. And it has a little bit more of a learning curve, but it's much more flexible, and it uses an aesthetics-based syntax. So most ggplot2 objects start with this core argument where you start with the ggplot function, then you name the data, and then inside the ggplot function you name the AES function, where x is the x-axis and y is the y-axis. So this is essentially defining the skeleton of your plot. You're telling ggplot what the x-axis is, what the y-axis is, and where the data is coming from. And from there you build up additional things onto it, either by adding more arguments inside of AES, or, and often, by adding geom arguments with pluses following this entire ggplot function. Geom is short for geometric element. So let's look at an example. So this is how we're going to do the exact same box plot we saw before using ggplot. So we start with the skeleton, ggplot, our data is DAT, inside this AES argument, and AES is for aesthetics. We have x-axis is domain, y-axis is RESP, and then outside of that, I'm going to do plus geom box plot, and that tells our ggplot we want a box plot. Here's our plot. You can see aesthetically it looks a little different, but it's the same plot. Otherwise, it's got this gray background, doesn't have the same style whiskers, but same plot. And here's an example of the scatter plot that we did before. Here we do it the same way. We have this core ggplot argument. We name the data. Here we say the x-axis is age, the y-axis is RESP, and here instead of geom box plot, we add geom point, and this gives us our scatter plot. So you may be thinking, this looks way more complicated. Why do I need this to just produce these same plots? And the reason is because you can do much more interesting and complicated plots with ggplot more easily than you can with base R graphics. So, for example, factorial or grouped plots, which in these examples, I'm going to show grouping by color, but you can group by all sorts of ways. You can group by for line plots, line type, or for scatter plots, shape of the points. But in this case, we're going to look at color. So here you see same thing as before with our box plot. The only addition is inside the AES argument. I added fill equals month. Fill is the inside color of the objects, and then we still have geom box plot. And here you see now we have a grouped box plot separated by month. So we have RASP by domain and month. So this is a factorial plot. And we can do the same thing with our scatter plot. Here I used, instead of the argument fill, I use the argument color, because for points you don't need to use the fill argument, you use the color argument, but otherwise it's the same idea. So changing some of the labels and aesthetics, this involves adding additional functions onto the end of the ggplot. So the LABS function, labs, is how you can set axis labels and titles, stuff like that. If you want to change the background from being that sort of gray background that's the ggplot default to white background, you can add the theme BW argument. There's also the general theme argument or function, which allows you to set several aesthetic tweaks. And then if you want to change things about the X or Y axis, you can use the scale X or scale Y continuous, or sometimes it'll be scale X or scale Y discrete, depending on what type of variable you're using. And that allows you to modify the scale. So here's a nice kind of ugly chunk of code, but I'm going to explain it piece by piece. So here we start with our normal ggplot function. So we're calling the data, and then we have the aesthetics argument inside AES. We set what X is, we set what Y is, and we set what we're grouping our plot by. So domain is our grouping variable. And then again, we have geom point. We're saying we want a scatter plot. And then after that, we have this labs function. So here I'm saying the x-axis should be titled age, the y-axis should be titled preference. The color argument here is what the legend is going to be titled. So because we're grouping by color, if we want to name the legend, we inside the labs argument, we call color domain. And then a general title, I'm just going to give this plot a general title of scatter plot. Then I'm going to use theme BW to take away the gray background. I'm going to use theme legend position equals bottom to move the legend from the right-hand side to the bottom. And then I'm going to rescale the x-axis so it goes from 0 to 100. And here's our plot. So you see we have all our titles, our axis titles, our general title. You see that the legend is on the bottom. The legend now has the word domain with a big D, and just a little bit prettier plot than what we had before. So we could go into a lot of detail about plotting model results by hand. We've so far looked at just sort of plotting our actual raw data, but a lot of times what we want to do is plot our model results, and there are ways to do this by hand using lots and lots of complicated ggplot arguments. Fortunately, people have begun to produce more and more wrapper functions that can help for us, and one of the really nice ones is called ggeffects. This is the ggeffects package, and then inside the ggeffects package there are a few different options. One of them is one we should talk about is called the ggpredict. So this is a way to look at model predicted values. So the first thing I'm doing here in the second chunk of code is I'm creating a regression model. This is the same model we looked at the end of the stats tutorial video, where we're having preference predicted by domain, month, and age, where age is sort of a covariate. So then I'm going to create a ggeffects object by calling the ggpredict function on the model, and I'm going to set the terms that I want to predict. So here the first term is what the x-axis is going to be, and the second term is the sort of moderator, that's the factorial term. It's the grouping term. So here I'm saying I want domain predicting preference grouped by month. So once I create that ggpredict object, I just call plot on that object, and this gives me a ggplot. And once I have a ggplot, I can add additional things like if I want to customize my labels like I did here, or rescale the y-axis like I did here. So really, if you just called plot on the LM plot1 object, that would give you a plot you could look at. It just wouldn't have these titles and it wouldn't be scaled quite the same. So this is the plot that it gives us. You can see it looks a little bit different than the defaults in regular ggplot, but otherwise it's quite nice looking. It gives us these nice little means and these error bars. So these are 95% confidence intervals. You can change the type of confidence interval with certain arguments. If you look at some of the help pages for the ggpredict function. So that was if we have a categorical predictor. Now we can look at with a continuous predictor, and we can look at a model with interaction. So here I'm refitting our interaction model from the previous video where we have, actually this is a totally different interaction model. I'm interacting domain with age. So here we have a categorical variable interacting with a continuous variable. And you'll see why I want to do this in a moment. So the next plot we're going to make is we're going to have age predicting preference, and we're going to have age grouped by domain. So I'm going to do the same thing I did before, where I'm going to create a ggpredict object, and then I'm going to plot the ggpredict object and add a couple of ggplot arguments on after that, so I can customize the axis labels and the scale of the y-axis. And it gives us this nice little grouped line plot with these confidence ribbons. And so this is what we have when we have a continuous predictor moderated by a categorical variable. But what if we want the reverse? What if we want a categorical variable moderated by a continuous predictor? The one thing you have to know here is that you need to specify the levels that you want the continuous predictor to be grouped at in the grouping argument. So here we're having domain predict preference grouped by different age levels, and here the age levels I chose are 25, 35, and 45. And then once again I create my object, I add a couple ggplot arguments on so that the plot has the correct axis titles and all that stuff. And now we see what our plot looks like. Here we have domain predicting preference, and then we have these 3 different age groups that I specified in the square bracket.